Okay, so yesterday you would have learned how to find the derivative of sine and cos by drawing the graph of sine and cos, and also draw the graph of derivative to deduce that the derivative of sine is cos, derivative of cos is negative sine, and then we can use the result to differentiate tan x because tan x is sine over cos, which become using quotient rule, and also derivative of sec x. And then we got a formal proof of the derivative of sine x and cos x using differentiation by first principle. We got the derivative of sine x and the derivative of cos x. And then next we got all these formulas. These formulas can be found from the reference sheet, which is over here. Reference sheet, this part here is given to you. And then we're going to, oh, we don't need this now. Okay, okay, and then we've got all differentiation of all 6 trigonometric functions. These are all summarized below. And then you did some question on differentiation using quotient rule, chain rule, product rule, and then find the equation of tangent. After this, then we found out how to differentiate sine of x degree and also differentiate sine x and compare the two of these. Okay, yeah, let me just quickly go through this again. So to differentiate sine x degree, you just write sine. To change x degree to radian is pi x over 180. So write pi x over 180 like this. And then to differentiate that using the chain rule, you get pi over 180 sine pi x over 180, which is sine x degree. Oh no, whoops, cos, that's a cos. Which is equal to cos x degree with an extra pi over 180. Okay, that means that as you see the graph, if you graph one against degrees, after 10 degrees, the graph just goes up very little. So therefore, the gradient is actually very small. So if you draw the tangent at the origin, which is like this, that's the tangent. Let me use a line. Tool on page 12. 19 is the previous one. There. Okay. So if I draw a line like this, that's the tangent, which is very low, right? That's a tangent. Doesn't allow me to. Yeah. Yes, just like this. Okay, so that's the tangent. And the gradient of that tangent, if you substitute on a calculator, you do pi over 180 times by cos 0. And if you do it in radian mode. Okay, 0.017, so it's very small. Like that. As you can see, it's very flat when it's a degree. That's x degree. Whereas when you do it like this with radiant, 2 pi is 360. If you find the derivative, you get just cos x. And then when x is 0, y dash is 1. So the gradient is exactly 1. So that's the difference when you have degree and you have radiant. Oops. Let me just move this off. Oops. Okay, alright. So let me delete this. Okay, let me draw again. Okay, so that's equal to 1. So that's the difference when the graph is in degree and the graph is in radian. So that's why we have to learn radian, so that the gradient of the graph is 1 at the origin, rather than the gradient is like 0.017. Okay. What else are there? And then we compare that with exponential. We see something very similar with exponential. So if I draw the graph of this, if I find the derivative is e to the power x, when x is 0, the derivative is e to the power 0, which is 1. So that tells you the gradient of the tangent is 1, like that. Whereas for 2 to the power x, right, the gradient, if you differentiate 2 to the power x, is equal to 0.69 times 2 to the power x, isn't it? And if you find the gradient at x equal to 0, gradient at x equal to 0, the gradient will be 0.69 times e to the power 0, which is 0.69. So the gradient is different. M is 0.69. So very similar idea with the trigonometric functions. So in exponential, we have to create a new number called e so that the gradient is 1. Whereas in the trigonometry case, we have to create a new concept called radian in order to make the gradient at the origin equal to 1. All right, good. Any questions? So today we're going to do integration after this. And that's all the parts for TUNIT. And then we'll just do the extension 1 component of integration next week. All right, now we're on page 14. Page 14. Go to page 14. Actually, not 14. Is it 14? Yeah, it's 14. Okay. And then you also use Newton's method to solve this equation. Just remember to use radian mode when you do so. All right, now we're on page 14. Okay, so we got these formulas. All of these are on the formula sheet, so let's look at the reference sheet. The reference sheet is over here. So we see that all 4 formulas are given over here. So that's the formulas. Only 3 of them. And if we go back to here, there's this one you have to learn off by heart. So that's no longer on the formula sheet, just these 3, but not this one. Okay, so let's do this question using these formulas. Let's look at the first question. The first question is, so look at the reference sheet. Integral of cos is positive sine, and you divide by a. So in this case, you're going to write sine 3x minus 2, but you divide by the number in front of x, which is 1/3 of c. Yep, like that. And then you try the next one. Integral of sine is negative cos 5 minus 7x. Like this. And then you just divide it by negative 7 plus c. Right? And when you divide by negative 7, it becomes positive 1/7 cos minus 5 7x plus c. And that, so that gives you the answer. Okay, good. And how about the next one? Sec squared is tan, so you write tan 4 minus x plus c, and then you divide the number in front of x, which is negative 1, so just put a negative in front. And then we've got some definite integral to go through, so you try to do this. We'll do integral, and then, all right, so it's not a lot of questions we'll go through today. Okay, we did that. Yep. All right, let's do a definite integral. So what you do is integral of cos is sine x over 2, but you divide by the number in front of x, which is half. So you do 1/2 like this. Square bracket pi and pi over 3. That's the first step. And then 1/2 is 2. So put a 2 in front and start substituting sine pi over 2, substitute pi into x. Then you do minus, substitute pi over 3 into x over 2. How do I do that? You just have to do this, do pi over 3 multiplied by half, rather than pi over 3 over 2, because that's confusing. So write this times by half. And then if you simplify that, that will just be 2 sine pi over 2 minus sine pi over 6. And if you know your exact value, that will help you. So the sine pi over 2 is 1. What's sine pi over 6? Half. 1 minus half is half. Half times 2 is 1. Good. Now try the next one. Have a look at your reference sheet. Oh, that's not on the reference sheet, so you have to remember. Okay, good. So sec is just sec and tan times together, you get sec 2x. And because there's a 2, you divide by 2. 3 pi over 2 and 0. Okay. And then you do half sec. And then do 2 times 3 pi over 2 minus sec 2 times 0. Close bracket. And then if you do that, you will just cancel the 2. And then you end up getting half sec 3 pi minus sec 0. Now, to do sec, you just do 1 over cos on your calculator. So you do 1 over cos 3 pi minus 1 over cos 0. Alright, what's 1 over cos 3 pi? I think it's negative 1. Just double check. It's in radian mode. 3 pi, it's negative 1. And then I think 0 is 1. Alright, 1 and negative 1. So you write 1 over negative 1 minus 1 over 1. So that will be negative 2. So the answer is negative 1. It's your final answer. Try the next one. Okay, good. Next one, integral of sine is negative cos x. And then you substitute 5 pi over 6 over 0. So you write negative cos 5 pi over 6 minus cos of 0. Now, what's cos 5 pi over 6? So you have to look at the quadrant. In the second quadrant, like this. Now, what's the related angle? Pi on 6. And is it positive or negative? Negative in the second quadrant. So write negative cos pi over 6. And you need to know your exact value. What's the exact value of cos pi over 6? Root 3 on 2. So you have to remember cos 0 is 1. So you continue to do that. Let's draw a boxy. Continue on. Negative root 3 over 2 minus 1. Which there's no like term. The negative, you cancel both of the negative. Like that. As your final answer. So you do need to know your exact value in this topic. Alright, good. Any question? Let's move on to the next page. On page 15. Alright, page 15. Next page. The cos of x degree, change degree to radian. Like that. Use this formula and you write integral cos pi x over 180 dx. And then you write equal, integral of cos is positive sine pi x on 180. And then you divide by the reciprocal of this. So you do 180 over pi. Like that. 180 over pi plus c. And that becomes x degree. So sine x degree with extra factor in front. Yeah. Now, of course, you can compare with the other one. Compare if you're doing in radian mode, in radian angle. So compare with this cos x dx. You just get sin x plus c. So without this extra bit, like that. Okay. I think about this. Okay, good. So after this, we have to draw a diagram to find the area bounded by the curve. So whenever they say area, you should draw a graph of the graph of the curve. So it's y equal to cos x, 0, pi, 2 pi. You just draw a rough sketch from 1 to -1, pi on 2, 3 pi on 2. Goes like this. And then the area is now between pi over 2 to 3 pi over 2. So you can notice that it is negative. That's okay. You just find the integral first from pi on 2 to 3 pi on 2, the x, and then you just work out. Alright, good. So integral of cos is sine. Put in the limits, 3 pi on 2, pi on 2, sine 3 pi on 2, minus sine pi on 2. So it's -1 minus 1, which is -2. And of course, the answer should be negative because it's below the x-axis. So you will say area equals to the absolute value of that, which is just +2 units square. Done. Okay, all finished. Okay, volume. How do you get volume? Rotate it about the x-axis. You have to go like this. V equal to integral pi y squared dx from a to b. So in this case, you go integral from pi over 3 negative to positive pi over 3 negative. So you go negative pi on 3 pi on 3 y squared, which is sec squared x dx, like that. And they just work out. Now notice this is an even function and it's symmetrical, isn't it? The region is symmetrical. If the region is symmetrical, you're allowed to double and go from 0 to pi over 3 instead. That could make it faster. So you get 2 pi. What's the integral of sec square? It's tan x, good, tan x, pi over 3, 0. Now you need to know what tan pi over 3 is. Tan pi over 3 minus tan of 0. What's tan pi over 3? It is, now you need to know your exact value. What is it? √3 tan 0. You can tell from the graph it's 0. So the answer is 2 pi √3 is your volume. Okay, good, done. Got one more question to go through. Area between two curves, then we're done. Area between two curves. Okay, good. Let's move on. area between two curves. So you need to find out where does the two graphs intersect. There's a graph of sine x and the cos x. Cos x is this, no, that's cos x, that's sine x, right? The cos x will be in purple. This is y equal to sine x. Y equal to sine x. In purple, in blue. Okay, good. So what you need to do is to find out where they cross. Find out where they cross. So you have to solve them simultaneously. So you just write sine x equal to cos x. Now, how do I solve this equation? We've seen that before in the trigonometric equations. Yep. Anyone? Divide both sides by cos x. Yep. Why do we do that? Because we want to get rid of the cos. And what's sine x over cos x? Tan x. And then you have to examine which quadrant. Tan x is positive in the first, in the third quadrant. Find out the related angle. The related angle is related equal to tan inverse of 1, which is pi on 4, 45 degrees, pi on 4, pi on 4. So actual x is pi on 4, and the angle in the third quadrant is pi plus pi on 4, which is equal to 5 pi on 4. Okay, so you get equal to pi on 4 and 5 pi on 4. Okay, let's label this. So you got pi on 4 here, 5 pi on 4 there, like that. Okay, now what do? We need to find the area in between the two curves. And there's a formula to do that. We do y2, which is the one at the top, minus the y1. So the area will be y2 minus y1 dx. And the limit, starting limit, is pi on 4 to 5 pi over 4. That's why I need to get these numbers, so I know where my integral starts, where my integral finish. And then you just have to work this out. And remember what's y2? Y2 is sine x minus the cos x dx from pi on 4 and 5 pi on 4. Okay, have a try working it out. You will get these surds in your expressions, and you have to simplify the surds. Leave your answer in exact form. I have a try working it out. Yeah. So derivative integral of sine is negative cos minus sine x 5 pi on 4 over and pi on 4, and then substitute negative cos 5 pi on 4 minus sine 5 pi on 4 minus negative cos pi on 4 minus sine pi on 4. Okay, so you need to know your exact value. And then when you do this, you just have to draw a quadrant. 5 pi on 4 is in the third quadrant, just like using this diagram over here with the related angle pi on 4. So that's 5 pi on 4, so the related angle is pi on 4. And in the third quadrant, both sine and cos are negative, so you become negative negative cos pi on 4 minus negative sine pi on 4 minus negative cos pi on 4. And if you remember your exact value, cos pi on 4 and sine pi on 4 are both 1 over root 2. So you get 1 on root 2 plus 1 on root 2 minus negative 1 on root 2 minus 1 on root 2. And you just have to simplify. If you expand the negative, you get both positive. So you get 4 lots of 4 on root 2 rationalize the denominator, you get 2 root 2. Alright? Yeah, 2 root 2 square units. Right, we're done. So that's how we do the question. And please look at your reference sheet as you do the question, because that will help you to find the formula during the exam. So this part's now done. So everything on the reference sheet are now done with that integral of sine and cos, everything. Go back. All right, good. So today you do exercise 5.10. 5.10 today. All right, good.